In this lesson, we are looking at how to find and graph the inverse of a linear function. So here, let's look at the notation we are going to use. So you can see this notation, f raised to negative x, will represent the inverse. The misconception here is when students see that, they always, or some of them imagine that it's the same as reciprocal, but it's not, as you can see there. So now let's do a quick review of some things we learned in Algebra 1. So the domain represents the input values. The range represents the output values of a relation. Something else you ought to remember is this one here, and it says the domain of the inverse is the range of the original function. So what we are saying here is that while x represents the input, y represents the output, those values in domain and range, they switch. And we are going to see the application of that in the next example. So here, let's start by writing the domain and range. So the domain is n, range is going to equal what? So here the domain is equals to A, B, and C. Range is going to be given by 1, 2, and 3. So here we are told to find the inverse. So how do we find the inverse? So we find the inverse by just switching the x and y. So negative 2, 3, 0, 6, negative 6, 5, 3, negative 4, and 5, negative 6. We're just switching them. So that is the inverse of that relation. So let's go to another example. So here we are told to find the inverse of the given function, and we have some steps we are going to follow. So here, let's follow the steps. Step 1, substitute y for f of x. So I have y is equals to 3x, that doesn't look like a 3x minus 2, and then substitute y for f of x. We have done that. Interchange x and y. So x is equals to 3y minus 2. Then the next step is to solve for y. So I'm going to do that by adding 2 on both sides. So when I have done that, I get x plus 2 is equals to 3y. And then my last step is going to be dividing everything by 3. So I get y is equals to x over 3 plus 2 over 3. I'll write it now in notation form, is equals to x over 3 plus 2 over 3. So that's the answer. So another example. So we do step 1, y is equals to 2/7 x plus 1 over 2. Then I switch x and y. Plus 1 over 2. Then my next step, I'm just going to simplify that. So I'm going to subtract 1 over 2, 1 over 2. So I get x minus half equals to 2 over 7 y. And then I just need to get rid of this fraction, isolate y, so I multiply by the reciprocal of that, 7 over 2 So 7 over 2, I do the same on the other side, but I need to multiply by the reciprocal. So here, see this is gone, so I get y is equals to, I'm going to distribute this inside, so I get 7x over 2 minus 7 over 4 when you multiply. Then I can write it in notation form. So I get 7 over 2 x minus 7 over 4. So that's the answer right there. Okay, now let's see how we can graph the inverse function. So we are given this function, graph it by the inverse. So, and then graph the inverse on the same function. And here I'm just going to do the graphing. Okay, so we start by graphing. So I see that m is equals to 1/2, and the y-intercept is -3. So y-intercept is -3, so b is -3. What does that mean? I'm going to start with the y-intercept, so -3 right there, and then I go up 1 over 2, up 1 over 2, and then up 1 over 2. Then I can connect. See, I can get more points because I can see the thread. So then I can connect with a straight edge. Okay, that doesn't look very straight, but it's good enough. And then I'm going to find the inverse, and I want you to see what I'm going to do here. And you're going to see when you do it this way, it's very easy. Okay, so I'm going to take the points which I'm given. So for example, I have 0, I have 0, -3, 0, -3, and the inverse of that is going to be -3, 0. So -3, 0. I can take the other one, 2, -2, 2, -2. The inverse of that is going to be -2, 2. So -2, +2. And now I can see the thread. So 1, 1, 2. So you just need, or you could even keep getting more points, like this is 6, 0, then 0, 6. Then we can see the thread here. So we can keep going. Okay. 1, 2, 1, 2, 1, 2. And we can connect our points with a straight edge. And I encourage you to graph this on paper. And when you look at these two, what transformation maps f of x to the inverse? And I want you to see that this is, a transformation. Let me use a different color here. We can be able to see it. See, this is a transformation along this line here, and I'm going to show a dashed line here because it doesn't exist, and this is the line y is equals to x, and all the transformations are reflections on, so this is reflection on the line y is equals to x, and that happens every time.